Good morning. It's so nice to see all of your faces here. When we were planning this particular session, we had the topic in mind of practical issues, which is often the first session that we have at the Molecular Virology workshop. So for those of you who haven't attended before, we usually like to open with kind of bread and butter practical topics that are relevant to all of us in the clinical lab setting and public health lab setting. So the title of the session is It Must Be Friday at 3 p.m., Common Challenges for a Molecular Virology Laboratory. And we were thinking of this kind of as a lighthearted session of venting and complaining perhaps about some of the things that arise in the lab that are less than ideal on a Friday at 3 p.m. But Dr. Schutzbank's wonderful message there, the reminder that sometimes those Friday 3 p.m. calls are not so annoying. They're actually potentially life-saving or really important diagnostic endeavors. So for this session, we have three terrific speakers, and we'll do questions after each session, and then at the end, we'll ask the speakers to stay in case there are questions for the entire panel. So our first speaker today is Dr. Susan Butler-Wu. She is the Director of Clinical Microbiology at LA County and USC Medical Center and an Associate Professor of Clinical Pathology at the Keck School of Medicine of USC. She earned her PhD in molecular microbiology at Tufts University and completed her postdoctoral fellowship in tuberculosis at the University of New York, or NYU, excuse me. After completing a postdoctoral fellowship in medical and public health microbiology at the University of Washington in Seattle, she was the Associate Director of Clinical Microbiology at the University of Washington Medical Center until she moved to her current position. Her research focuses on rapid diagnostics for infectious diseases, and she is a member of the editorial board of JCM and serves on working groups in both CLSI and ASM, and she's a diplomat of the American Board of Medical Microbiology. So I'll welcome Dr. Butler-Wu, who is kind enough to join us for a session at 9 a.m., which I believe is 6 a.m. her time, after just coming back from Europe and then dealing with a CAP inspection yesterday. So we're really appreciative that she could be here with us. And so the title of her talk is One Size Does Not Fit All, Finding the Right Size Molecular Platform for Your Lab.
Thank you, Dr. Graff, and thank you for the invitation to be here. It's really tremendous to just be in person again and see all of you guys. So those are my disclaimers that it is currently, I think, 6 in the morning LA time, and my body has no idea what time of the day or night it is. So with that said, so when I was thinking about putting this talk together, this is actually a really challenging thing to try and talk about in 20 minutes because the technology is so varied and so vast, it's basically impossible to review everything. So instead, the point of this is maybe this is something you're doing at 3 p.m. on a Friday as you're pondering the existential meaning of life, but more of a philosophical sort of consideration of how we start to think about this. So really, this is like a 38,000-foot view. I'm not going to get into comparing platforms and channels and things. It's more going to be just like generally, how do we kind of approach this? So really important thing is this is a really sort of bespoke decision, if you will, because what's right for your lab and the decision that you make about what's going to be best for you and your patients is going to differ from my colleagues up here on the stage with me and each of you in the audience as well. And so how you think about this can be really simple, just to solve an immediate issue, or it can be really complex as you're thinking about, moving to a new space, or consolidating, being in a more consolidated lab system, your hospital is taking over other hospitals, et cetera. And so the bottom line is that there's loads of opinions out there. So how do we begin to think about this? So in the wise words of the dude, I think, isn't it, hey, that's just your opinion, man. So that's basically, this is just my opinion about this. It doesn't mean it's right or wrong. So when I was thinking about this, really, I feel like as you start to think about trying to pick the right molecular platform, it can really feel just like you're drinking from a fire hose in terms of information. But if we all put ourselves back to, little over 2 years ago, it really felt more like this. We were all just like scrambling to get whatever you can get. And so one of the things, just as another disclosure, Where I work is more like a giant community hospital. So we were really at the mercy. We had no ability to do lab developed testing. We were really at the mercy of what we were able to get our hands on. And so we were just trying to do whatever we could do. And so everyone sitting in this room who works in a clinical lab can attest to the fact that we now have, most of us have multiple platforms to test for one virus, which is kind of remarkable. It's on a scale that none of us would have really encountered before, certainly not a lab like mine. So this is a survey that was done, I think it was maybe the second or third survey that the Association for Molecular Pathology did of clinical labs. And you can see that 80% of labs that they surveyed, and I think there was maybe 113, had 3 or more different assays for SARS-CoV-2. And then in the face of all of this, especially as you're starting to think about what's the right platform for your lab, is just really the scourge of the supply chain. So, I mean, who in this room can say that in the last couple of years during the COVID pandemic, they were never short of something? I mean, if you can put up your hand, I'll be shocked. But certainly most of us were just constantly fighting for scraps. So in that survey, what you can see is that pretty much throughout the categories that are on there on the left, be it PPE, tips, reagents, cartridges, you name it, pretty much everybody experienced some sort of a shortage. And a whopping 93% of labs that were surveyed reported that either there was a delay or a decrease in testing that they had to implement that was directly due to supply chain issues. So, as Dr. Schutzbank was relaying his story about that patient with HSV encephalitis, every one of these tests comes from a patient, and 93% of labs had test delays as a result of this. So I would say when we sort of philosophically think back on this, we kind of had to essentially channel MacGyver. At least I felt like that in our lab. We were just MacGyvering everything. I remember somebody asking me, who's not in the field, what's your job? Like, what are you doing? And I remember saying, I shake people down. I shake down companies. You're just trying to get what you can. And so that sort of scenario where we have so many different test platforms, I want to just point out that's still an option for meeting your demand, right? There's nothing wrong with that. That's what many of us are still doing. But some of us now, as we sort of hopefully things are more settled, would like to start perhaps channeling Marie Kondo and trying to reduce unnecessary things and simplify our lives. And so in the next portion of my talk, we're going to kind of talk about how that could look. So really, when you boil it down, I think there's 2 fundamental questions. So what are you trying to accomplish? Are you trying to let me grab my tea, sorry. Are you trying to really reduce the number of platforms that you use and really consolidate testing to one? Are you now being tasked with taking over another hospital and you have to expand testing? And again, that's going to completely fundamentally change what the right answer is for you. And then really critically, what is your lab setup, either now or as you move forward? Is your lab, what are they able to do? What do you reasonably think they could be pushed to do? And is that going to be changing in the next couple of years? And fundamentally, how you answer those 2 questions will completely shape how you approach this. So I made a flow chart because that's what I do. It's not using the appropriate, whether it's a circle or I didn't do any of that. I'm too tired for that. But follow along with me. So when we're trying to think about choosing the right platform, essentially the key decision point is this going to be a workhorse for what you're trying to do in your lab? Is this going to be something that either does a very large volume of tests or something that does the majority of your tests? Really, it's like the bread and butter of what you do. And so I'm going to focus on the yes side of this. So if that is what you're looking for, is this something where you're going to do 1 or 2 assays? In that case, do you have the ability to, either you currently have the ability to do a non-integrated extraction, so you have a separate offline extraction, or is it something that if you can't do it right now, you think that you would be able to do? And so that's going to be our scenario 1 that we talk about. If the answer is no, so there's no way that your lab can or will be doing offline extraction, it all has to be integrated, or you're not a high complexity lab, then we start to think about instrumentation that has a more integrated extraction and or is moderate complexity. And again, if you're looking for a workhorse that's going to do multiple assays, this might be the path that you end up with too, an integrated extraction and or moderate complexity. And then thirdly, you start to think about turnaround time. So if there's one thing we've all experienced throughout this pandemic, is very demanding people demanding results 5 minutes ago, not understanding that no, the PCR does not take 10 minutes after it got sent to the lab. One of our friends had I think a nurse come to the lab and tried to start rooting through the specimen rack to pull it out to like demand that it be run. They were obviously disciplined, but there's been so much focus on turnaround time. And I don't know if you guys ever watch Ronnie Cheng. He's a comedian, but I think he calls it the Amazonification, like I want it now and eat it now. And I think that philosophy really fed over to COVID testing and has really impacted us. So obviously if something, that should say less than 4 hours instead of more than 4 hours. So if you really need a rapid turnaround time, and that's something that is part of your workflow and going to be part of your workhorse workflow, then you're really going to want to start thinking about random access platforms, maybe the way to go for you. And so the important thing too is, I mean, the right answer might still be more than one thing, right? Very few of us are going to have just one PCR instrument, and certainly now we don't. So if you're not so worried about turnaround time, that can lead you back to the integrated extraction situation. Now, it's important to point out, as we'll get into, that some of these large analyzers do have, random access capability. But at the end of the day, they're never going to be as fast as if you have a true random access instrument. That's just the reality of the situation. So looking back at that survey, which if you haven't read it, it's a really fascinating read. And certainly, I would love if they did it again, just to see where we're all sort of at. It's important to point out that when you look at the breakdown of the types of labs, out of the 113 labs that were surveyed, only about a quarter were community hospitals or community hospital system labs, and I think that reflects these data. I think a quarter were commercial labs, and the rest was a hodgepodge of major academic medical centers, public health labs, et cetera. And so looking in their survey, the testing was pretty evenly split between labs using platforms that had integrated versus non-integrated extraction, so 52% versus 48%. So delving into scenario one, so where you're looking for a workhorse for 1 to 2 tests, and you have non-integrated extraction capabilities, and you really have a high demand potentially for volume. Obviously, you're not going to do any of this without automation. And so this is really where you really have to employ liquid handling. So there's going to be various steps, obviously, that this is required for. So moving samples into the deep well plate, also pipetting extraction reagents into the plate, and then obviously moving around extracted RNA. And so there are a variety of platforms. I'm not going to get into specific ones, but depending on the scope and scale of what you're trying to accomplish, your liquid handling needs are obviously going to be varied, and that's something you need to factor in as you're planning for this. So there are combinations of semi-automated and fully automated options. So with the semi-automated models, obviously they are maybe a little bit easier to get going. They don't require you to have very, fully defined methods built into your software, but it does require much more hands-on involvement and control. They tend to be a little bit less expensive and have a smaller footprint. For some of the more fully automated liquid handlers, these can be, once they're going, apparently they're great, but they can require an awful lot of assistance from the vendor. As Dr. Abba can speak to, you essentially have the person living in your lab working all of this out for you. And so that might be something that in a pinch you can maybe plan for, but when you're trying to get something going really quickly, that can make it challenging. These tend to be larger and they tend to be more expensive, but when you have them going, they are less hands-on and more walk away. So I think this is a video you can see the liquid handler at play here, just going from the specimen tube to the deep well plate. Another consideration, which we're going to get into, obviously, is all the open tubes and the moving of specimens around. Obviously, at that point, then you have to think about what you want to do for your PCR itself. Obviously, if you're dealing with PCR tubes like in grad school and as a postdoc, you're not going to be super high throughput. So if you're really going for a high throughput workhorse situation, you're going to be looking more at either 96 well or 384 well plates. And again, there's liquid handling involved in that and a variety of different instruments available. And let me just say, me showing a picture of an instrument is not an endorsement, and there's many, many more. It's just, those are some common ones. So obviously, what you have to consider, there's, as I said, high instrument cost. Reagent costs can be lower. And then one of the nice things about this, if you invest in building this, is that the reagents can be sourced from multiple vendors, so they're more agnostic. One of the challenges that we'll get into that all of us have lived is when you are using a vendor-specific cartridge, it is a vendor-specific cartridge, and so they have you by the ghoulies with respect to what you can get and what you can't get. Obviously, physical space and engineering requirements. If you are a very large lab, then something like this is great. If you're not, then this can be challenging. And Dr. Abbott's going to be speaking to appropriate quality control and checks. But obviously, there's going to be, you have an open system, you have a lot of liquid handling steps in between. There's always the potential for contamination. There's also the potential lack of suitability in some cases for quantitation. And really just that ramp up time. If it's something you can really plan for and work on, and if you wanted to just bring on a new assay, then you have to essentially redo all the programming and figure out all the parameters, and that can make the ability to pivot quickly challenging. Obviously, the nice thing here is it opens up the possibility to have a lab-developed test versus a commercial assay. And so, obviously, many large academic medical centers are used to having LDTs. A lab like mine is not. The first time we had an LDT, which wasn't even for molecular, people lost their minds. They took a lot of hand-holding and coaching, and that's the reality for the vast majority of labs in this country. Obviously, assay volume is going to be a really big driver here. Is it worth it? Is it going to be an assay that you do a high volume of enough to warrant all this work? Some of the interpretation, if you're doing a test such as this, it requires a higher level of interpretation compared to a sample to answer instrument and assay where there's really minimal interpretation. Okay, so the second scenario then is where you either have many assays and or an integrated extraction. And so as with the first case scenario, this is really a balancing act. And some of these considerations are going to be the same for the different scenarios. But when you start to get into the more integrated extraction instruments, most of the platforms don't necessarily have the ability to do LDTs, lab-developed tests. So really, you're looking very closely at what the assays are that are available, how they perform, what the approved sample types are, and will I need to do an off-label modification, and is my lab really set up to be able to manage that? Again, depending on this platform, some of these can also be quite large, so we have to think about physical space, workflow, staffing is for everything. LIS is usually less of a problem in many cases because there's usually a build that's there in terms of an interface. But then we need to start thinking about batch versus random access. Is this going to be something that you're predominantly using for testing where you can wait a little bit longer, or is it something where you really need that rapid result? And then again, cost, right? You're completely dependent on that vendor for supplies. So I think this is an example of the thought process to go through. It's not saying that either the Roche or the Panther Fusion is better, but just sort of how you start to think about it. So both of these instruments, for instance, have they can accomplish a lot of testing in a 24-hour period. But importantly, the time to first result can be several hours, and there are differences between them with respect to batch testing versus random access. But I think when you start to sort of get into the details, and I will say this is a comparison actually with the original Panther, but I'll get back to the Fusion in a second, you have to start to pay attention to other things that are sometimes sort of glossed over a little bit, perhaps by the manufacturer, which is the number of interventions, what the total turnaround time is, and the number of specimens that are going to come out in that first result. And there was a really nice paper that Dr. Pinsky's group published where they looked at the Panther Fusion And they looked at the impact and throughput of running one versus several assays. And the bottom line is obviously, even though a lot of vendors will say, oh, you can run all these assays and this is our throughput, the bottom line is the more assays you run, the longer it's going to take for results to come out. So you want to start to think about this. Am I really just going to be powering through one particular analyte on this box? But the vendors are going to say you can put multiple things on the box, so then you got to start to really delve into what the turnaround time really is going to be. In some cases, it won't matter. In some cases, it may, depending on what that analyte is and what you're trying to achieve. And so then the third scenario is more of the random access and or smaller test volume. So there are many labs in the country, mine included, that we're part of a system, and so we do a chunk of the work, and a chunk of the other work goes to other labs within the system. And so in that case, we don't need the biggest box. We're more focused on, what's going to cover most of our tests and give us a relatively rapid turnaround time. And so I think there's maybe smaller considerations for this, although some still apply. Typically, these systems are smaller. They have a much smaller footprint, although there are, in the case of the Gene Expert, the Infinity, which is a bigger, essentially has higher throughput and higher capacity than the original 16 unit. So you have to say, again, what are the assays I'm looking for? What are the approved sample types? And again, will I need to do an off-label modification, and can my lab do it? What does the workflow look like? In the case of the Diasorn, it's not random access when it's running, you're locked in. But the way around that is, as any of us that have any of these instruments, you have multiple ones, and that's how you can kind of keep the testing going. And again, with these, cost has been a big thing, and I think in particular, allocation, right? Who has not dealt with allocation shenanigans, right? You get told all of a sudden, oh, by the way, flu season's coming, we're cutting your allocation for your respiratory panel by 40%. Oh, great, that's great, loads of time to prepare for that. So that's something that when you use these assays, although they're great, we've all experienced difficulties getting what we need. Hopefully that will pass. But it's hard not to be a little bit, I think many of us are probably a little bit bitter about it, to be honest. And I will say, even though many of these have to do with SARS, it's because there's lots of recent data comparing sort of throughput and things. It's not, and obviously the individual assays are going to have different turnaround times and things like that. But just to highlight some of the differences here between the expert system, the Diasorn, and at that point, Genmark had I think they maybe still do have a SARS-CoV assay, and just looking at what the turnaround time is, thinking about how many tests can you continue to access and load more in a random fashion as the assay is running, and just sort of fitting that with what your patient population is and what your provider demands are. Okay, so in conclusion, really, I think the closest analogy to how we were all rolling, at least I was rolling, was it was like a supermarket sweep is what it felt like. It was just like, get all the tests, because ultimately, vendors were not able to deliver, and so we were having to cobble together what we had to do. I am curious about what's going to happen to all of us that have accumulated all these other instruments, and one in my lab is a very expensive paperweight that we're not using at all. I will not say which one. And so we all like to think, oh yeah, I got to get back to that now and start to use it. The bottom line is, I'm not sure that we all will. There are many options available, and so really I think we've seen what happens when you're rushed into making decisions. So I think the next phase now is for us all to breathe and sort of carefully consider and go through all the options. Pay attention to the details on throughput, because often the reality is different perhaps than what the manufacturer is saying. So always seek out your colleagues and talk to them, in addition to looking to what's in the literature, your colleagues who are using it. And unfortunately, I feel like we're still always short of something, so I don't think that this is a resolved situation, even though we all feel more settled. I don't know how much this will continue to be an issue, but it does make future state planning challenging. And then I would just like to thank, I don't know where my last slide went. I have an acknowledgement slide that says April Abbott on it, and it's not showing up. So I just want to thank, there it is, Dr. Abbott for her wise words and sharing her experience with me of the pandemic, and for just being an amazing person. So with that, I will stop talking and take any questions. Thank you.
Thank you so much for that terrific talk. Just a reminder to everyone, feel free to post questions in the polling/chat app, but we invite you to come up and ask questions as well. I know it's been a while since we've been in person, but don't be shy. And then we'll have folks circulating at some point with our toss mic. So if you don't ask questions now, I promise we'll find a way to have you ask questions later. So I'll start with a question. We've got a couple of minutes. You alluded to this at the end, which was a perfect segue. So how are you going to decide what to do with those boxes in your lab? What are the factors that you consider with perhaps saying, okay, that paperweight's going to sit there, you may not end up using it? What are the things that you're weighing with all those various platforms that you might have access to?
It's a really great question, and I think if you had asked me that 6 months ago, 9 months ago, I had plans that have now been scuttled by just a decimation of staffing, that we're all dealing with. Everyone decided to retire at the same time because everyone's burnt out. I had plans to take one of the platforms and start to try to, do an LDT on one and to try to expand the test menu, but that particular platform is a lot more labor intensive than the other one or two platforms we use. And at this point, with the staffing that we have, where we're trying to decide, do we even get to do mycology anymore? It's not going to be, we're going to still do mycology rather than pursue that. So if I had the staffing I had 6 to 9 months ago, I would have tried to just really bring in tests that we send out. But that answer, sadly, is, if anyone knows any CLSs who want to move to Los Angeles, come see me. Yeah.
Perfect segue to our session later today on workforce issues. But okay, another question. Again, feel free to come up and ask questions. So I think many of us are concerned about future state if there are more boxes, like if the boxes that we have aren't exactly fitting our needs and there might be a different box or a different technology that we want to bring into the laboratory. I'm personally concerned that administration will say, you have enough. We gave you all this during COVID. You should not need any more for 10 years. So how do you envision, or will you envision asking administration for additional things if they become necessary? Let's say you had the ideal workforce.
Come on, H5N1, we'll fool them into thinking we need this other stuff. I'm totally joking about that, and definitely do not come on, H5N1. I think it's a really big challenge, and we've already dealt with that. We've already had that where administration is, wait, you want what now? And why do you need this additional, cartridge? Why can't you? So I don't know what the answer is. People have short-term memories, and I worry that all the attention and the spotlight that was shone on us is quickly forgotten. And so yes, it really becomes then about dollars and cents. So I don't know that I can answer that question. It's a challenge. I think we're all going to face it.
All right. I want to thank Dr. Wu for an excellent talk. If there are no more questions, we'll roll right along so that we can stay on time here. So our next speaker is, excuse me one second, shuffle my papers, Dr. Rachel Leisman. She received her PhD in microbiology and immunology from the University of North Carolina at Chapel Hill and completed a fellowship in clinical microbiology at the Mayo Clinic. She's a diplomat of the ABMM. She's currently an associate professor of pathology at the University of Kansas Health System, where she is director of the clinical microbiology and molecular microbiology laboratory sections. And she is currently serving as the president of the Southwestern Association for Clinical Microbiology. And her talk today is Enough is Enough, How Much Revalidation Do I Really Need to Do? And I know many of you in the audience have either not too distantly moved a lab or are about to move a lab, myself included. So I'm really interested to learn what I need to do from Dr. Leisman. So come on up.
Big green one. Okay. Thanks for having me. It's really great to see everybody in person again. This is my first conference back in person, so I'm very excited to be here. So I'm going to talk about revalidation. Enough is enough is a statement I've made several times over the last 2 years, and I have done more validations and revalidations than I expected through the course of the pandemic. I'm going to take a bit of a case-based approach, so trying to kind of understand practically what does CAP require from us, what guidance is out there. But at the end of the day, I'm largely going to tell you what we've done, and I'm really welcome and open to hearing if you guys have done something different, if you vehemently disagree with our approach to it, definitely want to have that conversation. So I show this comic a lot to my medical students, and I point out to them, usually when I'm talking about pre-analytic, analytic, and post-analytic phases of testing, that the laboratory is where the miracle occurs. And so I think about our validation studies really is making sure that that miracle works and proving that the performance of testing is working appropriately. So before we talk about revalidation, let's just get on the same page about the initial validation, so we want to get it right the first time. This hopefully is really familiar to everyone. I tried to put in the relevant CAP checklist items here just for reference. It's not all of them, so make sure you refer back there. But our qualitative FDA clear tests, we want to do our basic precision, accuracy, reportable range, and reference ranges. If we're doing a quantitative test, we've got to do a little bit more, still sticking with those 4, but adding calibration in order to verify our standard curves, as well as verifying our linearity, our analytical measurement range, and then our limit of detection as well. And then certainly if you are doing a laboratory developed test, be it qual or quant, we've got to do a little more work here. So adding in our analytical sensitivity, including limit of detection, and where applicable, our lower limit of quantification. Investigating interference and cross-reactivity is part of our analytical specificity studies. And then the LDT CAP checklist item includes kind of a comment of and others as applicable. So things to consider include investigating any carryover studies and potentially validating stability depending on your assay. There's a lot of resources available for that initial validation. This isn't an all-extensive list, but these are some of the resources that I really rely on when I have questions here. So obviously going back to your CAP checklist items, and all of the CAP checklist references for everybody are from, I believe, the September 2021 update, so tried to use and incorporate the most updated CAP checklist that I had. The Kumatech 31A is our verification. It actually has been discontinued, but if you've got one of those sitting around, it has some good stuff still in it. Clinical microbiology reviews and the clinical microbiology newsletter, I think, publish really nice practical papers. This isn't an all-extensive list, but there's some good ones that I rely on. Giving practical resources, including number of tests, what statistics to apply, how to graph those out and evaluate that data, and those are quite useful. And then the Changing Swabs JCM editorial is always a paper I keep in my back pocket. It has saved me a couple of verifications in conversations with our quality coordinators. So if you haven't seen that paper, check it out. It's, I guess, getting kind of old, but still a useful document. Okay, so that is all on validation, right? But what we're talking about here is revalidation. So you've already done your initial validation, you're chugging along with your testing, and for some reason you need to revalidate. So do I really have to revalidate, right? So the first question is why? Why would I bother to revalidate? Well, as always, we're gonna bother to revalidate because CAP makes us. So if CAP requires it, we have to do it. But realistically, the reason that we want to consider a revalidation is that there's an event or a change that might compromise the performance of that assay. So that could include movement of the instrument, any kind of major maintenance, any upgrades, including hardware and software upgrades, major changes to personnel, all would qualify under that kind of change that might impact the performance. So if you're doing something that's going to impact the performance, we want to cross-check and make sure that everything is still going well. Whoops. So when do I do it? Whenever CAP makes sense. But my guiding principle is if I'm asking the question, do I have to revalidate? More often than not, the answer is yes. But I think the thing that is challenging for all of us is to what extent. So if I'm going to revalidate, what does that mean? So we always want to do whatever CAP requires, but CAP really is pretty open and vague on what exactly you have to do. This is ultimately determined by the laboratory medical director, which is not all that helpful because unfortunately that's me, so I have to figure it out. And unlike the initial verification, there's really very little guidance on the extent of revalidation that's required. I looked pretty extensively for this and didn't find a whole lot. If any of you guys have have any papers in your back pocket that I missed, please let us know. But I found that there's very, very little guidance and a lot of confusion on when and how, especially to revalidate. So I thought I'd talk a little bit about what I consider when I'm thinking about and planning a revalidation study. So here are my major considerations. The biggest thing is going to be the extent of the change. So what did we do? Did we make a minor change or did we make a major change? I also take into account the historical reliability of the assay. Assays that in our hands are extremely reliable, where the QC is really tight, I might not do as extensive of a revalidation versus an assay that we struggle with or that has significant variability. I want to make sure that we didn't kind of move out of that significant variability. And then, unfortunately, sometimes these are surprise revalidations, and we are somewhat limited by the resources available to us. So what is your availability of validation material, right? If you only have 10 patients and you want to validate 20 patients, are you going to wait till you get those other 20 positives? What do you have time for, and what do you have available to you? And so those are sometimes limitations that we need to work around, where we can't always do maybe what we think would be ideal. Okay, so I'm going to take an approach of a case-based approach and just talk to you through some of the scenarios that have come up for me, where I've thought about revalidation and let you know what we did and what we're thinking about. Each of these has a poll everywhere attached to it, so we'll do the case and then show the poll everywhere. For anyone who hasn't used poll everywhere, it's like completely anonymous. You can vote however you want. And all of my poll everywhere questions are the same, so you can kind of think about it when we're talking the case, and the PE is on the next one. All right, so I couldn't get through this without talking about the C word, so we're going to start off on this. This is case one. We were on a break. So in June 2021, you discontinued one of your COVID platforms due to declining volume. When I think back to that summer, I wish that I had taken a few more naps, but instead we kind of worked on some other things. And then in December of 2021, you needed to bring that platform back online because overnight we had a significant increase in the number of testing volumes. So we had to bring that platform back online. So my question to you is, do you revalidate? And so our options are no, we're not doing anything. Yes, but I'm just going to run a bit of QC. Yes, but a mini validation, whatever that means. And yes, I'm going to do a full validation. All right. So I'm not going to spend a ton of time. Most of us want to do a mini val. Okay. So our relevant CAP checklist item here is going to be in the all common. It is 4805, and that is our intermittent or seasonal testing checklist item. So this checklist item requires two specific aspects to be fulfilled. One is that patient testing is suspended. So we wouldn't be asking ourselves this question if patient testing isn't suspended. That's pretty much always fulfilled. The second is, did you miss a PT, or if you're doing it APA? And that, I think, is the kicker there. So if you performed your PT or APA during the course of this, you didn't miss a PT cycle, you actually do not have to revalidate entirely. So you don't fall into this checklist item. It's not considered intermittent testing. So we always, if we're gonna take a break on an instrument and we think or we know that we're gonna bring that back, so a temporary send out, or in this case, we took an instrument down, we make sure that we continue to perform our PT or APA as required, because it means we can do a quick revalidation. So we basically QC'd our reagents, we double-checked a handful of known positive patients, and then you're okay to test because you're not falling under that intermittent testing. If you didn't do a PT or APA, so if you missed a cycle, you do actually have to meet the requirements for intermittent testing. And there are 3 requirements that are laid out by CAP. The first is you perform PT or APA within 30 days prior to patient testing. So most of us are probably not going to hit a PT cycle, so we would have to perform an alternative assessment of performance in that case. And that is 30 days before you start patient testing. You do have to do a method performance verification also within 30 days of patient testing. Generally speaking for these, unless it is a quantitative test, we're really going to focus on precision and accuracy, but that accuracy can be abbreviated, again, depending on kind of what your assay is and what that intermittent testing time frame was. And then if you didn't test for a long period of time and you missed some competency, you got to make sure your staff are competency. So you'd have to perform a competency assessment within 12 months if you fall under that. All right, so that is our intermittent testing. Case 2, maybe, is relocatovirus testing. The case names don't get better, guys. So due to laboratory space constraints, you validate a new multiplex instrument in a research location. Once validated, you're going to move the instrument into your clinical space. So this is a relocation. Do you need to revalidate? All right, so it sounds like, or it looks like, most people want to do some sort of validation and a little bit of split between if we're going to do mini, whatever that means, versus a full validation. And I agree that it kind of depends. So where do we fall with our CAP checklist item? We want to make sure that we adhere to the all common 3550. So this is a function check required. This function check specifically calls out major maintenance as well as relocation. So we're basically confirming that the instrument. Yeah, sure.
Is the movement from the research lab to the clinical lab in the same building, or is it in a different building?
Well, in this particular scenario, we are across the hallway, but that's a good point, and I'm going to talk about that in the next slide, because that's definitely going to probably sway you on your answer one way or the other. So we want to do our instrument checks. These are basically your maintenance checks, make sure that you didn't damage your instrument. But the biggest question is, to what extent do we have to verify? So in the test method validation verification section, in your standard verification CAP checklist, it says if an instrument is moved, the lab is responsible for determining that the method performance specifications are not affected, right? So still kind of vague, but you've got to confirm those specifications. All right, so not all moves are equivalent, which Matt helpfully pointed out, right? So there's a difference between moving across the hallway and moving to a new location or a new building. So one of the things that I want to consider here is, what are our potential environmental changes? So what might have impacted performance? If you're moving across the hallway, you're likely in the same HVAC system, humidity is the same, your testing personnel is the same, you're moving into your clinical labs, you're not worried about contamination. However, if you're doing something like moving to a new building, those things all might be different, and that is going to probably motivate you to do a more extensive validation. So for our across the hallway move, we did a pretty small revalidation study, just checking precision in a small accuracy study with a few patients from our verification, and we made sure we rotated testing across all bays. We are planning a full relocation to a new building, and for us, our plan is to do a full revalidation of that instrument, right? Because it's a pretty significant change in environment, and the move itself is more extensive from an instrument perspective. All right, case 3, nailed it. Your instrument requires a replacement of most of your liquid handler system. Following installation, the field service engineer performs function checks, tells you he nailed it, it's ready to go. You perform several FDA-cleared quant assays on this instrument. Do you revalidate? All right, most of us are doing a full validation. Interesting. So we approach this as a major maintenance validation. So our major maintenance validations are built into our SOPs and our policies on that. Similar checklist, so you need to do your function checks and then confirm performance is not impacted. Again, going back to the principle of, well, what was the level of maintenance? Is this minor major maintenance? In this case, we replaced our entire liquid handler system. So we did not what I would consider a full validation study, but more of an extensive revalidation. This is a quant assay, so we revalidated our calibrators. We did precision. We did not revalidate our linearity in this case. In this, we did 5 previous positives, 5 previous negative patients. You could certainly justify doing more. And importantly, we added a carryover study just because this was impacting the liquid handler system to make sure that we didn't have any potential for carryover contamination. All right, case 4, your swabs are in the Suez. I almost didn't include this because, to be honest, I don't remember what we did back at the time we were asking this question. But you're validating an EUA SARS-CoV-2 assay for use on nasopharyngeal swabs transported in UTM. UTM's in short supply, so you want to validate PBS. Transport media specifications are not listed in the EUA for this assay. Do you revalidate? All right, so we definitely want to do some validation, the extent of which a bit of split. So a reminder here, CAP has beefed up their EUA checklist. So if you haven't checked that out, definitely go back and read through that. There's a lot of really helpful information now in that EUA section that was not in that section when we were all thinking about this in early of 2020. So an EUA, as a reminder, is not considered an LDT, so you can approach this like an FDA cleared assay. Some additional information. So this is essentially from the checklist. So labs using an EUA assay have to follow the protocol as authorized. But there is a note that says, except for modifications allowed by the FDA. And so FDA pretty continuously came back and allowed additional modifications and sort of phrased those as they did not object. And so there is an exception in there for what you have to do. If the EUA letter of authorization specifically addresses sampling devices, you have to follow those. If it does not, it's up to the laboratory director. And it does state in there that a formal full verification study for each device or media is not necessarily required, but the laboratory must have defined criteria for specimen acceptance. So what did we do? I think I remember this vaguely. We went back to the literature. So Dr. Binnicker's group published a really helpful paper on different transport media's instability on there in May of 2020. It felt like it took 2 years to get that paper out, but it was just a couple months. So we really leaned heavily on that as far as a review of literature. You want to identify the modifications allowed by the FDA. So going back to that EUA website, figuring out exactly at whatever time of day you were asking this question was allowed by the FDA. And then this is the validation study that I think we did. We did basically spiking studies for all of these. So we did a spiking study for precision in testing in replicates. We did a spiking study in accuracy, so really trying to spike near our limit of detection, testing over time and making sure we weren't seeing any CT changes. And then one of our concerns was if you went from UTM to PBS, would we have any stability impacts? And so we did a spiking study and looked at stability, comparing that CT value over time, and then again, referencing some of the literature that had been published at the time on that. All right, this is my final case. This is a vendor amino acid change. You're notified by the vendor that tween was added to the extraction cartridge moving forward. Vendor states that the change will not impact extraction performance, although no data is provided. You perform an LDT quant assay on this using 2 clinical matrices. Do you revalidate? Yeah, so most of us want to do a full validation or pretty close to it. I agree with that. So, if you're using an LDT and the vendor is changing anything about those reagents, I think it's very important to go back and ensure that there's no impact on performance. This was a quant assay, so we revalidated our calibration. We didn't do as extensive of a precision study that we would have done for an initial verification of an LDT, but we did do a precision study, revalidated our linearity across the AMR, and did an accuracy study. Again, 30 positives, 10 negatives meets criteria for full validation. It's certainly less than we do when we initially look at these assays. And in this case, our comparator assay was cartridges without tween. So we were basically just trying to prove that what the vendor had changed had no impact on our assay. We did not revalidate our analytical sensitivity and specificity. So welcome anyone that would have done that. We didn't do it for a couple reasons. The first is that our linearity and accuracy data, especially at the lower end of the AMR, didn't indicate any concerns with our sensitivity. So we didn't see any concerns that our limit of detection or LLOQ would have changed when we were testing at kind of around that lower end. We also concluded that the tween addition was unlikely to impact specificity and didn't see any indications of interference specific to that tween. So those were aspects of an LDT verification that we did not revalidate in this case. All right. Those are the end of my cases. So in summary, you want to review your relevant CAP requirements prior to planning any revalidation. Generally, though, those CAP requirements spell out confirmed method performance, which isn't all that helpful in my opinion. So considering the extent of change in the historical assay performance when considering, and then importantly, document this similarly to your initial validation. So if you didn't document it, it didn't happen, and make sure that you're writing that up appropriately. That's what I have. I welcome questions, comments, and any arguments anyone has. Thank you.
Thank you so much, Dr. Leesman, for that excellent talk. Looks like we've got some questions from the audience, so I'll give folks a minute.
Hi, Rachel. What's that? When you mentioned some of those references up there as being old.
Sorry.
Said might be old.
I'm sorry.
I've aged a lot in the last 2 years,
Mike Leffelholtz, now with Cepheid. And when you mentioned some of those references up there as being old, it now makes me feel quite old.
I've aged, Mike. I'm sorry. It's been a long 2 years.
But I think one of the big challenges here is the kind of liberal use of the word validation or verification. And I've always been a stickler for, how they're actually defined in the CLIA regs or the CAP checklist. And they always refer to a test system. And and I think some of your examples here were kind of using the terms a little generically, like, and then the other point that I always make is that to your point that you raise, is that there are no regulatory statutes around a mini verification validation. You either do it or you don't. And you do it if there's a new test system. And a new test system is either something that you're using new in your lab, or an existing test system, something changes such that the performance characteristics change. And if it doesn't, it's not new. And so you don't need to do a validation or verification. You may need to do something else. Like if you move an instrument, you're not changing the test system. You might be impacting the instrument. And let's just demonstrate that the instrument still works. But that's not a validation or verification of a test system. And so that's just one example that
Yeah, I mean, I agree that we use those terms loosely. And I really hate the phrase mini validation. I feel like we use it a lot just to indicate we're not doing everything, but we want to do some function checks and do some previous. And, if you would like to suggest a alternative phrasing that isn't so wordy, open to that. But yeah, no, I agree. And usually, the regulatory is just confirm performance specifications. They don't specify that you have to do a validation. And so I think watching our phrasing in that is important.
I think wherever clarity can be achieved, say from CAP, y'all ought to pursue it because it benefits everybody. Including the manufacturers, right? Because we're often asked to provide reagents to support these verifications, validations, mini verification, whatever the case may be. And we were also called upon to provide some kind of guidance. Let's say a manufacturer has X sources approved for a test. We add some additional sources. Do you now need to do a new validation for those new sources? And sometimes that generates a lot of counter opinions, and so more clarity from the from the accreditation
Yeah,
organization.
certainly an area of hot debate. And I agree, clarity from a regulatory perspective and more kind of field-supported guidance, too. There just really isn't a lot of guidance out there on what you should do. And so I think it's all just whatever our opinion is at the moment and what resources we have available at the moment. And sometimes what our vendors tell us to do, for sure.
Yeah, thanks.
Hi, Rachel, Dwayne Newton, Biorad Laboratories. Really liked your talk. The cases were great. I have a question about the last case that you discussed. Would your approach have changed if the vendor provided data to show no effect on performance?
Probably not, because don't believe anybody. I take trust but verify.
Even if it's me and my name is on it now?
I take trust but verify very. It depends a little bit on the assay, maybe in the robustness of their data. We might have done fewer specimens potentially, but honestly, I don't think so. It would have been helpful in a pinch. We had the cartridges. I think we got about 4 to 6 weeks notification in that case, and we had plenty of cartridges. So we had the resources available to do, a full verification. If we didn't have those resources, I might have, wanted some additional data from the vendor that would have been helpful. But ultimately, no, I don't think so.
And then what about I don't know what the right word is, the significance of the component that changed? How important or where in the process?
Yeah, I think certainly really important, right? So, and kind of where did they put it in? How much? What were those changes? Adding tween versus adding a different reagent versus, changing primer and probe sequences, I think would drive. If they changed a primer sequence, we would have done your analytical sensitivity and specificity, for sure. So that component did play into how we planned out the extent of the verification.
Did you have communication with the vendor, or was it just, you received a notification and that was all that you were relying on, was the information provided that way?
Yeah, we ask questions. Every vendor is a little bit different in how the extent to which they will give you information. And so in this case, I didn't really feel comfortable that I fully understood the extent of the changes, and so we elected to do more patient samples and a more extensive validation. But I absolutely always try to communicate with the vendor and really as deeply as I can understand what that change was and what their data shows. How did you prove that there was no impact on performance? And try to get at that. And sometimes you can get it, and sometimes you can't.
Thank you.
All right, we're out of time for questions. Okay.
Denied? Am I denied?
No, I can't deny you. You're one of the organizers. Go.
Quick question. So, Rachel, really great talk. You mentioned in a couple of cases the number of positives that you would have done. My question is, if the test has multiple analytes, is your number all of those analytes together? So one was 30. Would you do, if it had 3 analytes, would be 10, 10, and 10? Or is it 30 per analyte?
Yeah, I just want to emphasize that those numbers were what we chose to do. I all but made those up, right? So 30 isn't the right thing to do. It's just what we decided to do. So for most of those cases that I think I gave numbers, it was primarily single target. But if you were doing something like a multiplex, I rely much more heavily on my external QC for that to touch every analyte, and then we just kind of try to test across. If you've got multiple targets, testing across multiple targets. I think it's important you don't just do a single target, but realistically, you can't always get equivalent across all of your target. True of multiplex, but even we've had some revalidations of our HSV 1 and 2 and in different matrices, and you just don't always have those patients either stored or available to you. And so we really try to do the best we can and then supplement with spiking studies or external QC.
Got it. Thanks.
All right, one more round of applause. Thank you so much for that excellent talk. I want to acknowledge that there is one question in the chat that I'm hoping we're going to get to after the next talk, because I think it is really relevant to some of the subjectivity and confusion around this information that we could probably all talk about all day. But we'll move on to our next and final speaker in this section, Dr. April Abbott. She's the Director of Microbiology and Molecular Diagnostics at Deaconess Health System and an adjunct faculty member at Indiana University School of Medicine in Evansville. She obtained her PhD from the University of Texas at Houston, completed a clinical postdoctoral fellowship at the University of Washington. She's a diplomat of ABMM and a member of the CLSI subcommittee on AST. She speaks nationally on topics related to AST, molecular markers of microbial resistance, lab utilization, antimicrobial stewardship, and the role of laboratory infection control, among other related topics. She has a number of manuscripts and has co-authored book chapters on the topics of AST and the Manual of Clinical Microbiology. She most recently has been locally and nationally recognized for her efforts in building and sustaining a high-complexity molecular laboratory that provides SARS-CoV-2 testing for a region in southern Indiana and northern Kentucky. And I think we can all agree that she's been just an incredible workforce during this last 2 years. So without further ado, I'll turn it over to Dr. Abbott to talk about where there's smoke, there's fire, the importance of paying attention to red flags before it is too late.
Thank you so much for having me here. And like everybody else that's been up here, I feel like I need to give my testimonial and say this is my first time out of the hole and in person. So if I have odd behaviors up here that you're not accustomed to seeing, it's because I'm not used to public. So, I'll do my best to keep it under control. I think, again, we all see these issues that arise, and so we kind of look at these things as red flags. And what's really common is that you'll have questions that come out of the blue, and you're just not really sure why that person's even asking you this question. So I'm going to bring up some different cases here from a case-based approach of things that I've seen, and I'm going to give you my self-appointed expert opinion on how these should be handled. And so you also may differ from my opinion, but interestingly, as the staff know in the laboratory where I work, because they got me a button that says I am always right, hopefully you will appreciate that by the end of this talk. I can convince you. So because I've been holed away and have done nothing other than COVID testing, I have no disclosures as it pertains to this talk. So the objectives here, really we're going to discuss some small signals or smoke and review the steps to how you recognize whether this is really a smoldering fire, and then discuss your remediation steps after you've come to conclude that this is actually a dumpster fire in the making. So the case of the failed quality control. So this is something, again, it's not really part of our validation or verification, but it really does hinge upon whenever we do QC, it does really show us some steps that maybe we should have implemented during our validation or verification, and you'll kind of see how these things kind of play a part and a role within each other. So upon monthly review of QC records, our molecular supervisor noted that this is for a test that is an FDA cleared test, it's unmodified, it's a moderately complex assay, so really something that we are expecting pretty decent performance. We're not particularly worried about our QC being out. So on this one particular instrument, as they're doing their monthly review, they noticed that we had a non-template control that actually had amplification. And the run proceeded. The instrument didn't stop the run, and there was really no note. And so this really threw us because we were operating under the assumption that that instrument would not allow this to happen. And so from a reporting standpoint, we realized, we kind of have made a misstep here. So again, this being a moderately complex assay, we just didn't really expect this to occur. And so when we talk about QC, and this is a busy slide here, but I pulled out the CAP requirements, and we really talk about how often we need to be performing QC. And as pointed out earlier, the things that we put in place as our checks and balances are going to differ based on the assay itself, the analytes, whether or not it's something that we're comfortable with that assay. But you can see that you have to at least have some sort of written QC procedure. You need to have some policy around how often you're going to be doing this. And it's pretty vague. It really doesn't give you, CAP doesn't give you very specific requirements how you go about meeting these qualifications. And so for us, we really did have this proceduralized as to what we should have occur, but it wasn't something that was necessarily in the face of the technologist that was performing the test. And so this was actually missed. So for mod complex assays or sample to answer ones that are qualitative testing, you can't perform daily QC. If you're in a position to do pos and neg controls every day, then you live in a far richer environment than I do. So most of us are going to take the approach of developing an IQCP. And so for us, whenever we bring on a new assay, if we're uncomfortable, particularly with that platform, maybe that instrument's new to us, or it's an assay that we weren't really able to robustly validate or verify, specifically verification at this point because we haven't modified it, then we may transition just to weekly up front so that we can get comfortable with the assay. But our goal in life for all of these is really to move to monthly QC, and that's really the land in which we live for most of these assays. And also it depends on the frequency of testing. So if it's something that our technologists aren't going to be performing that very frequently, there's some additional interpretations involved, or there's some gaps there, then maybe we'll just do QC as we run the assay. So again, there's differences in this. And with COVID testing or SARS-CoV-2, what we found is that we were getting shipments every week and we were burning through those reagents, and so we were doing weekly QC anyway because we were doing lot shipment QC. So again, there's some nuance to this. So for us, IQCP is mostly monthly QC for all assays that don't require more frequent testing by the manufacturer. And so to the point made earlier, yes, it is helpful to have the manufacturer outline some of this stuff, but we want to see that it's very broad. We don't want to be pigeonholed into doing something that's really not going to be something that we can actually meet those requirements. So in our case, we use basically, I love that most of you are probably using some electronic form. We do not. We use the good old paper-based form. And so we just had a generic form. And one of the things that we realized is that although we had acceptability limits set in our procedures, it really wasn't visible on the form. And so again, because this was an unexpected result for us, so the solutions would have been just to go back and instead of just having a checkbox that says, yep, positive negative QC worked, maybe we should really incorporate having them put in what those CT values are as a double check for them, and then having that QC range at the top of that box, and then maybe even developing assay-specific forms. So it's easy from a paper-based perspective. We only have to make one form, but maybe that's not what's best from the technologist's viewpoint, because I could see where they didn't really have a bump in the road to keep them from making that mistake. And so whenever we find these things, we always reincorporate that back into our training and competency program. So we want to make sure that we had a misstep, we saw some smoke, we don't want to have it create a fire somewhere else. And so we really do a good job of trying to incorporate that back into our program. So at this point, we felt like we reached out to the vendor. They said that should never have happened. We're not sure. We're going to look into that. But what was interesting is, so we really felt, again, we'd had no problems out of this particular instrument. We'd had it for over a year running a particular assay with no failed QC, and we were doing lot shipment QC basically every week. So it wasn't something that we thought, there's an issue here. We just thought it was an errant result that, happens from time to time. So what was interesting about this is it happened to coincide with us implementing a flu-AB-RSV assay on that particular instrument. And I would say, too, this isn't just one instrument. We had 4 of them that were the same instrument type. And so during that verification, because I don't know about you, but we didn't see any flu B for a long time. So we didn't have any patient samples. And so when we encounter this where, maybe we're not in the cycle of a respiratory season, or we don't have the samples that we need to do a full true verification as it would stand for me, we typically, or I shouldn't say we, the formal we, I will put in place some caveats to what we can release and what we can't in terms of our results. And so what was really interesting here is that because we didn't have any of these, I made the decision, hey, it's not really flu season. If we get some positives, let's go the extra mile and confirm these on one of our alternate assays. And so like everybody else for COVID testing, we have at this point 3 or 4 different assays in which we can do influenza testing. And so we made that decision, and I feel like that's really the right thing to do. If it's something we were not able to do patient testing, I am of the opinion that you should probably confirm some of these original results that you get. So lo and behold, we get this influenza B result with a CT value of 38, and so per our protocol, they went on to confirm that on a different instrument. And it didn't confirm. And so then we said, hey, let's throw that on a different one, and it still was not detected. And so then we realized, hey, could these 2 things actually be related? And so we really went about then, that was sort of, again, an additional red flag for us. Hey, maybe we have a bigger problem here. And so this was something that one of our technologists got me in the middle of, the dumpster fire for which we have lived. And so I would say at this point, we're kind of at that orange flame. Like there's maybe something there because now we've seen 2 events, and so we're really not sure what this means. And so we went back and we looked at this from really different angles. So is this a training and competency issue? So is it something that we have new hires or new people that are working on this particular instrument that aren't fully trained? Have we had some deviations? We observed the workflow. So basically the people that run that assay, we set about watching what they actually do. So that's part of our competency assessments, obviously, but we hadn't done that in a while. We weren't up for 6 months for some of these newer trained employees. So we wanted to see, are we reintroducing bad habits, or is there some sort of deviation that's occurred? And then we started doing wipe testing. And so typically we perform this quarterly, but we have it in our policy that we can do this on demand when we suspect a contamination event. So at this point, we're suspecting a contamination event. And so now we're full on dumpster fire because we see that there's amplicon. And so, at this point, we realized something's gone awry in terms of that training or our practices here in the laboratory. And so this is what happened. So we have a meeting, and there's some tears. Everyone's tired, right? So they're wore out. They don't want to participate. But there are others that are blissfully unaware, and they're just making bad decisions. And there's some shame involved, some hair pulling, and eventually everybody just needs to take a nap. So my kids were disappointed they couldn't come to Florida, so these are my children. And so, this is just life, and we've had a really rough 2 years. And so, it's not a blame game here, but we had really deviated in terms of those safeguards that we put in place, specifically around containment. We just weren't really meeting them anymore. And so it's important because whenever you look at the Federal Code of Regulations, it really talks about for things that aren't in a closed system. But I would argue that you're going to see these things pop up even if you use a closed system. And so we really needed to be better about kind of separating our spaces and being more deliberate about our unidirectional workflow. And so one thing I will say is that we are actually really good about this with regards to specimen handling. And so I feel like at this point I need to kind of give you some background in terms of the laboratory space for the molecular laboratory. So back in 2019, I had set about to say, there's 2 things that I never really wanted to ever do, and at this point I need to see everybody's hands because I need to make sure you don't have a sharp object to throw at me, but there are 2 things in which I said after fellowship and my original director position that I will never do, and those are virology and molecular. And so here we are. But we set about, having that conversation in 2019. We don't really have a true functioning molecular laboratory. We probably need to get there. We were still looking at sample to answer sort of technologies, but things with a higher throughput. We have a Panther, but we were really looking to kind of expand that testing menu. But then 2020 hit, and there was a space in which we realized that we could kind of take over and build a molecular laboratory. But we were kind of stuck with the space that we had, and we were very fortunate. It was an old laboratory space, so it already had casework, it already had drops for electrical and things like that, but we couldn't really move things around. So where things were situated in terms of the casework, we had to work around it. There was already a functioning biosafety cabinet. We just needed to buy additional ones. So we had really a leg up on a lot of people in that we had a very functional space to start with. But they said, this is all temporary because this is going to go away in a couple months. And so, just make it work with what you can, but we're not going to spend any money, right? So I think you guys have probably heard this as well. So we had to basically figure out how to live within our means. We had no money, but we needed to build a lab. And so, one of the things to keep in mind as well is that we really set about saying we're going to support the lower half of our state in terms of SARS-CoV-2 testing. And also we have hospitals in Illinois and Kentucky, and so we knew that there was a likelihood that we would also funnel in samples from those states. So we really needed a way to get samples delivered from our central processing area, but also a drop-off point where we had couriers that were going to come in from the drive-through locations and drop specimens off. And so again, at our peak, labs are all different, but we were doing about 2,000 or 2,500 tests a day. And so we really, not at the time we started, but we did get there. And so we really were deliberate about making some of those decisions in terms of separating out and having different spaces for specimen processing. But unfortunately, we couldn't really consolidate that all into one space. And so we had a specimen receiving area, and that's what you see kind of in that top picture there, where we had lots of computers where they could come in, drop out bags of specimens. We would have 4 or 5 people working there to start separating them, to put them into the workflows for the different instruments based on whether it was outpatient, inpatient, instruments because we did testing for skilled nursing facilities and nursing homes during outbreaks and things like that. So we really had to have a program to have all hands on deck to separate samples and then take them to our processing area. So that was then separated up front a little bit, and we had several workstations up there and biosafety cabinets to then get those separated and off to their instruments. So in between those is where we had sort of our very first commercial assay that was planted there. So again, it wasn't great in terms of the unidirectional workflow, but it worked well enough for us because we didn't allow people to kind of take the same gloves into those spaces. The processors never went into the technical area, so there was some separation. So again, you have to think about your risk mitigation here. So with closed systems that are at a lower risk, they're not at complete, they still have risk. And so what we did is we put up as many physical barriers as that we could. We really tried to control the environment, so we had strict rules about movement of samples. So as an example, there are certain rooms within our system in which they only use a very specific colored rack or specific colored gowns. And so we really tried to implement thoughtful rules to help people notice when something was deviating. We also implemented a process which was very difficult during the peak of the pandemic, which was that you still have to change your gloves. And so the hospital's saying, reuse your gloves, and we're telling them you cannot reuse your gloves. And so that was hard, and it was a challenge, and we had to figure out how to overcome that. And then to ensure competency in the molecular techniques, such as pipetting. So again, like was discussed, I mean, we had real issues with finding staffing. And so you really had to reinforce some of these techniques in people that had never been in a molecular laboratory ever. And then monitor our positivity rates, failures, and also something that I wasn't a huge fan of previously, but now I've kind of embraced, is that there is really a place for wipe testing and making sure that you're monitoring your contamination. So adherence to standard molecular safeguards is really important. We did not see errors occurring during the processing steps, so they were happening during the test setup and performance. And so again, what we noticed is that people were just tired and they were overworked and they had found workarounds. So although the wipe tests were positive, these are in fact closed systems, right? So we felt like the risk for contamination inside an individual test cartridge, because we had no other QC failures throughout this entire process, was actually pretty low. And when we identified what the issue was, it wasn't just one issue in that we'd contaminated the inside of our instrument. That obviously was problematic, but it was the sealing of the cartridge that was not occurring, which was allowing probably that amplicon to get back in there. And so we observed errors that kind of were additive in effect. So another case here is a case of the low positive. So during the validation of a SARS-CoV-2 TAC-path assay, we noticed what appeared to be late amplification. We would see just these little blips at the end, and we really didn't know what to do with it. And because we were new to the EUA for TAC-path, and like again, we brought up a high complexity molecular laboratory, this was really our only assay. And so it was very hard because we didn't have other platforms to really evaluate extracted RNA on. It was an issue for us. So we really looked at this and we thought, oh my goodness, there's like a huge contamination issue going on. But again, we didn't really have comparator methods, and that can be problematic. The low positives were sporadic. They weren't something that we could identify as like right next to a hot positive. They just popped up. And then we really didn't have a ton of samples at that level that we knew that were quantitated. So it was really hard to figure out how to determine whether these were really true low positives. If we'd repeat a whole bunch of times, we'd still see it, or whether this was really an issue or an error due to contamination or something else. Molecular reagents are expensive, right? And at the time, we're really living hand to mouth in terms of how many tests we can perform, and can we really provide a robust evaluation of every little issue that we see, in the sense that we would have BC before COVID, which I heard somebody say, which I thought was amazing. So, dealing with new assays or modifications can be a challenge because there may not be literature, you may not have that peer-to-peer experience like you would with some of your other assays whenever everybody's trying to come up and everybody has a different system. And so what we found out is, you guys probably know, that Thermo Fisher said that, a lot of this is really due to inadequate vortexing and centrifugation. And so you should implement routine checks of this. And so that was really an eye-opener for us, because we realized this isn't an us issue per se, this is an assay issue. And so the resolution was better revolutions for us. So basically we had this little benchtop guy that everybody had said this is fine, yes, we recommend this, and we just could not get it to work. And so we made the decision to switch to something that was more stabilized and it solved our problem. And so we really implemented very disciplined practices around vortexing. We went through a whole competency program with that. And then we made some changes where, we just burnt extraction reagents and PCR reagents at that point. Like, we made the decision, we're gonna make sure our plates are balanced because we cannot repeat testing on all of these samples that are doing this, and we really wanted to make sure we weren't giving out errant results. And so we found that it was just very finicky, and we had to watch for invalids and low positives as our trigger to then go back and see if we had deviated in that practice for PCR prep, specifically, again, the vortexing and centrifugation. And so in our laboratory, on this particular instrument, this high complexity instrument, we do repeat samples that have a CT of 35 or greater. And so again, we needed to get rid of this from that problem because we're redoing the ones that we suspect may be low positives. We're putting them on a different instrument, and so we just couldn't go back and repeat them all. So that's a little bit different than this other scenario where we have a cluster of low positives. And so that's something in our interpretation guide, we obviously review every single well, but the techs are trained to specifically look for clusters whenever they look at their plate. And one of the things I should point out here is that we actually do our extraction in a different room than what we have for the other testing. And so we do have a more unidirectional workflow for that. And so we have 4 different rooms that are set up, the 4th one being in that main area. But room number 1 is where we do our PCR prep station. Room number 2 is where we actually make our reagents for extraction. Room number 3 is the extraction room. And then 4 is where our quant studio lives. And so we do have a better workflow set up for containment in that particular space. So this is our liquid handler and our extraction instrument. So this is a Hamilton Star. Again, not an endorsement, just what we have. And so you can see that whenever you're using this particular instrument, that robot, that arm is moving over open plates, over reagents. And so there's a high level of contamination risk involved in using in a system such as this. And whenever we're doing extraction, it does extraction of 4 96 well plates at once. And so we're doing extraction in a different format than what we run our PCR, which is in a 384 well format. So where you find your well during the extraction process is not where your well is going to end up during your PCR process. And so you have to keep that in mind as you're seeing clusters. They're not the same as what they are during the extraction and the PCR. So there's 2 different pieces to keep in mind. So reasons for contamination during extraction include just a snotty sample. So we train the processors to make sure that, like, if it's something that you cannot get all the stuff out whenever you de-swab it, then that goes to a different instrument. It doesn't go on this one because we don't want something to string across the whole panel. And then spraying into adjacent wells during the dispense step. So we spent months with the engineer from Hamilton really looking at how to minimize any sort of well-to-well contamination, months. And so it was something that we felt like, from the liquid handling standpoint, we had to tweak that assay quite a bit to get it to work in our hands. And so it's not for the faint of heart. There was also issues where, because you're using reagents that may make bubbles, and so you can have those pop, and so knowing the dispense height and how to really limit your potential for cross-contamination during the extraction process, and then droplets that may happen as the dosing head is moving across different plates that may fall. So again, just liquid handling steps that have to be perfected whenever you're dealing with these. And so again, to point out, whenever we're talking about clusters, the ones where you see the arrows, because it stamps a plate from a 96 to a 384, there's going to be a well space in between, so the samples during the extraction process are not going to be exactly next to each other whenever you look at your PCR. And so again, this is just an example here where you can see that there are hanging drops, and so we have to make sure that as those move across, or that head moves, it would kind of push itself, and you could see droplets that fall. And so it probably doesn't project very well, but we could actually see droplets. And so I would get down and video every single step during this process so that we could go back to the engineer to say, we need this fixed. And so again, from the 384 well format, that step is the most precision-based step, and so it actually takes from the 96 well plate, and it's going to dispense that into those tiny, tiny 384 wells. And again, it does this in sort of a stamping fashion where it goes to each one. And so this, from the perspective of the manufacturer, is the step where you're most likely to introduce contamination from well to well. So we obviously look at carryover very specifically in our 96 well plate and what may end up in the 384 well plate that may cause it to splash. And so the added challenge here is that you have wild swings in positivity. You have wild swings in like what your CT values are at different times. And so all that really plays a role into what you're able to to do in terms of this, if you have a CT value of greater than 35, that you have to actually repeat that testing. So everyone reviews our wells, and when we have these clusters, it requires second level review, but that's virtually impossible to do whenever you have greater than 50% positivity, right? Like, you're not gonna be able to meet all these demands. And so the typical rate that we would see is probably about a 5% repeat rate, and we are able to sometimes resolve them by looking at the plates and saying, like, okay, we see that there's an issue happening, and so we need to remake like our PCR balances and things like that. So there are sometimes things that whenever we do this, it's not just to ensure the correct patient result, but also to look at gaps in our practices or things that maybe are going to impact other things downstream. So again, we do this for invalids. We have very specific rules of what we're looking for, and then we provide troubleshooting guidance to the technologist as to how to really intervene before it happens with another sample. So this other case is a case of the doubting James. So this is one, our president at Deaconess, his name is Dr. James Porter. So I get a call from him, and he says, hey, you know, I know you recently brought up this new assay, your LD or your EUA, the TechPath assay, and we're seeing a lot of positives. So we're thinking maybe you didn't do a good job in your validation. So we think you're wrong. Can you go ahead and go back and look at that? So, you know, one of the things that we do is we monitor our statistics, and so, you know, I was a little bit offended, but we went ahead and we went back and looked at it. And so the question becomes, you know, should positivity rates be monitored by your assay or instrument? So we all know that we do these comparabilities, but should we be looking really at positivity rates that are more specific to a particular assay or instrument? And so does that really help you in identifying testing errors? And so again, if we did a good job of our verifications, validations, then we probably would have noticed this already. But I do think it's a good practice. So here's positivity rates. So we had at the time 6 different assays for SARS-CoV-2. And so you can see that, in fact, our inpatient ones, which are represented mainly in columns 1 and 2 and 3 here, were a little bit different than the one that was represented in column number 4. But importantly, these are completely different patient populations, right? And so what you can see here is that as we move down, you get more outpatient samples. And as you're very familiar with, outpatient samples is where you're going to see your signal as you start to enter a new surge. And so what we were seeing is just that we were entering a surge. We hadn't had inpatients that were positive. And plus, if you look at something like our rest pan, we have rules set up to where you're not going to get a rest pan right out of the gate. Those are set up later after you've probably already had your COVID test. And so I think I have one more, and I'll try to rush through this because I'm out of time, but this is a case of the odd question. And so we have a new processor that asks, hey, can I use that hood in the back? And we have biosafety cabinets in the back, and so somebody said, sure, of course, you can go back there and process samples. And so I walk through the laboratory, and I'm looking for her, and lo and behold, she's using our PCR prep station to process SARS-CoV-2 samples. And I was like, oh goodness, that's not what I said, but it was something along those lines, a little more, you know, animated. And so at the end of the day, like, they don't know what they don't know, right? So probably like you, we had all kinds of randos in the lab, and some from HR, they were well-meaning, but like, they just don't know what they don't know. And so really, what's the risk of contamination to those specimens? Probably not great, right? You know, like, let's be honest, these were collected through a drive-through, you know? So it's probably not that big of a deal, but the risk to the employee was probably fairly significant because, again, she made this one error. There may be other errors there. So in times of duress, we really have to make sure that we're still teaching those people that enter the laboratory about good practices. And so, you know, again, we really take these examples as we see something. We want to take that as a teaching opportunity and re-implement that back into our competency and training programs. And, you know, we've all had a real rough go of it. And so, you know, again, like my kids show, I'm a bit dodgy at home sometimes with them, and I can do that in the laboratory sometimes, but we do try to circle back to everybody, make sure that, you know, like, again, we're a team, and we're really trying to make sure that we're just doing the best that we can for each other and for our patients. And so with that, I'll take any questions that you may have.
I don't know if this is on. Might have time for one quick question, and I don't want to hold us up from the break, so Esther?
Esther Babadi, Sloan Kettering. April, that was awesome, thank you. Actually gave me nightmare to see all you're doing for those low positive. So my question is, for all of those that you repeat over 35, understanding that those are low positive, it's sporadic in terms of being detected or not on repeat, did you ever look back to see if any of those patients on follow-up testing became positive?
Yeah, so that's an excellent question. So in terms of the clinical piece of this and whether we thought the greater than 35 ones off of the TACPath assay were they the right answer? Was the one from the Diasorin or Cepheid or, or Panther, was that the right answer? So we do fully appreciate that there are different limits of detection for these assays. And we found that, when we were more rich in our ability to do repeat testing, sometimes we found that probably our EUA-based TACPath assay was the right one, but we were uncomfortable with it because of the fact that we'd had so many issues with what we perceived to be potential contamination, that our trigger for calling something on that particular assay greater than 35 and trusting the other assay, which probably had a higher limit of detection, we would end up calling them negative if they were negative on the other assay. So we trusted our commercial assay, which maybe we shouldn't have. And we did, in fact, go back and look up some of those patients, and some of them were patients that we were known positives a few, weeks ago. And so there were, it's a mixed bag, and I'm sure you've encountered that as well. Like, it's almost impossible to figure out, are they just, somebody that has a little bit of virus, but then the next day if we were to test them again, it would be gone? Like, are we just picking up something that really is clinically insignificant, or does it actually mean anything? So the decision that, again, I made at the time was just we were gonna trust our commercial assay because we didn't have time to do that. But what I will say too is that throughout this entire process, we've made numerous positional changes with our robot, and we found that our invalid rates and our ability to really trust our instrument changes with how much fine-tuning we do. And so we started off with like a 15% repeat rate. It was horrendous. And we now are way below that. And it, again, obviously changes with, if we can determine, like, okay, this is clearly a splash because it's only amplifying one gene, and I didn't want to get into all this, but there are other things that we do where we say, we're going to call this one not detected because there's invalids next to it. Everything looks like this is an assay issue and not a true positive. So we do have other things that allow us, once you have a supervisory review, to call those not detected. So there are other nuances to that, and we did go back, but there's just too much data. It's just, those data are overwhelming to kind of put into one concise thing.
Thank you. All right, I want to keep us on track because we've got quite a long day ahead of us. So one last round of applause for Dr. Abbott and all of our fabulous speakers on this panel.